This is chapter 5, problem number 3. So the question asks to determine the support reaction. Okay, most likely will be both on point A and point B. All right, let's look at this one. This type of support is many balls over here, so it can move freely in the x direction. Over here, the force in the x direction should be equal to 0 because it can move freely. There's only one force acting on it, and that is the normal force, and it's pushing up against it. With this type of the pin connection, so you can have a force in both the x and y direction. Before we do anything, I'm going to write down the magic formula over here. The moment or the torque is equal to x times f in the y direction minus y times f in the f direction, x direction. All right, so we see all those forces acting on different positions. So I'm going to call this as my origin. So this point is my 0, 0. I'm going to get the coordinate of each point over here. So for the point over here, I'm going to call it, so this is point A, B, probably call it C over here, and call it D over here. Okay, so over here is 4 meters. So the x component over here, so from here to here, it will be, so this is 45, so it should be equal to 4 times cosine 45, and that is equal to 2.83. That means the height over here will also be 2.83. All right, so what happened with the x value over here? So I'm looking for this point over here. It will be equal to 6 times cosine of 45. That is equal to 4.24. 4.24 over here. So the y will be about the same. The y is 4.24 from the top to the bottom over here. All right. So what is the position over here at point D? So at point D has 2 meters, so it should be 4.24 plus 2. Okay, so from here all the way to here, it will be 6.24. That is the x, and the y will be 4.24. The one over here, the x component will be another 4 over here. So if you do this way, you add 4 to it, so it will be 10.24. That's the x of this one, and the y will be over here. So that is 2.83. All right, so we just find out the coordinate of each point. So how do I set up the equation? We may need more space, so let's write everything in a very clear way. Now we have, so this is our pivot. We have 1, 2, 3 different forces acting on it. We're going to use the same formula. All right, so the first one is the x component. Okay, so this force, we have both the x and y component because it's 45 degrees over here. So the x component is going to the right, it will be positive. So it will be positive 5 times cosine of 45 degrees, and that is equal to 3.54. So going to the right will be 3.54 Newton. Going down should be negative 3.54 Newton. Okay, so x is over here. It is 2.83, so 2.83 times force in the y direction, that is negative 3.54 minus y, that is 2.83 times the force in the x direction, that is 3.54. All right, so we are done with one of these. How about this point? Okay, so The force in the x direction is equal to 0, so we only have the first term. So that should be equal to 6.24 times negative 10 kilonewton. Okay, so the other one is over here. It's going up, so it will be x times y. Okay, so it will be plus x over here is 10.24 times y. The force in the y direction, we don't know. That's why we call it force B. So let's put a B over here. And this term, because in the x direction, is equal to 0. So that's all we have. So all this will be add up to equal to 0. So I'm going to use my calculator. Okay, well, you cannot see it that easily. Okay, so it is 2.83 times negative 3.54. So the first term, this term is negative 10. Okay, minus this term again. This is negative 10. This one also negative. Negative 10 minus this one, negative 10. This one, it is also negative. So we just shift this a little bit. So minus 62.4 and then plus 10.24 times B. So that is equal to 0. Let's see if it makes sense. So this force makes it go clockwise. That's why it's negative, negative. This one will also make it go clockwise. That's why it's negative. And this one at point B is going to make it go counterclockwise. That's why it's positive. All right, so I just have to add this up and divide it by this number. So it will be 10 plus 10 plus 62.4 and then divided by 10.24. All right, so at point B is equal to 8.04 kilonewton. The lucky number for this problem, again, it is 1. That would be the lucky number.